Hello, this is Bradley Needham. I'm going to be talking about the pointer to implementation or pimpl idiom in C++. It's also known as a compiler firewall or a handle body pattern. We want to do this because we want to separate our implementation from our interface so that if we make changes to our implementation, it does not affect our clients in that they do not have to recompile. Normally with a C++ class, if I change my parts of the private implementation, adding a new member or adding a new function or changing something to that private implementation, it will cause a recompile to the clients because they include the header file and the header file has changed. We also would like to maybe even provide some sort of binary compatibility so that we could have a library which would prevent users from having to recompile, and they could simply either relink, whether that's dynamically or statically, with our library without having to recompile any of their code. So what I'm going to do is I'm going to take this simple class employee and I'm going to convert it to use the pointer to implementation idiom. Okay, so let's start here and let's have a look at our simple class. We have employee, it has a constructor that takes a name and ID. We have a couple of member functions to get that information from the employee, and maybe some to set that information as well. And then down here we have the private portion of our class, which is the name and the ID. We could also have private member functions here, but in this case we just have the data associated with the class employee. Let's look at our little test program. The main here simply creates a couple of employees, prints out the name and their ID, resets the name, prints out the name and ID again. And let's go ahead and run that and see what our output is. And we get what we're looking for. We get the name of the employee with the employee ID, the changed name, same employee ID, and the second employee. Let's look at our implementation now. Very simple implementation, has the constructor that sets the member variables and then provides implementations for each of our methods. Now, how would we convert this to use a pointer to implementation idiom? So what I'm going to do is I'm going to replace the implementation, the private implementation here, with simply another structure which is the implementation, which will represent the implementation for me of my employee class. So I do that by providing a struct impl, and notice I'm just going to forward declare this. This will be my implementation type for the class employee, and I'm going to use a standard smart pointer class for my data type, which will be the representation of my employee implementation. Now I'm going to have to provide a destructor here. Now that I'm managing a resource, I want to provide the destructor. If this was a raw pointer, inside my destructor I would call delete of the pointer type, but since this I'm using a standard smart pointer, it's going to manage the lifetime of the object created underneath it, but I still need the destructor, and I'll just implement that either as a empty destructor or a equal default, which will basically allow the unique pointer template to correctly manage the lifetime of my implementation object. Now, a couple other things I'll need when I'm doing this, and we'll get to them, is of course before my employee type was copyable and assignable. If I want to maintain those, now that I'm managing a pointer underneath, I need to provide the class here with a copy constructor and an assignment operator. So I'm going to go ahead and put those in here as well. Okay, let's go ahead and now look at how our implementation will change. So now of course I need to declare the structure impl. I only forward declared it in the employee.h header because I wanted to avoid having any compiler dependency on the size of the implementation. The compiler knows how big a pointer is, so that's all he needs to know about that structure at that point. But here, where I'm going to actually be using that structure, I'm going to have to declare it. Okay, so here's my structure employee impl. Right, this is a structure that is scoped by the employee class itself. It's a private structure type. And you notice that my constructor pretty much looks like the constructor that was for employee. And here are the other private portions of the employee type. So now how does my employee constructor change? Well, remember, my employee constructor now no longer has, the employee type itself no longer has a name and an ID. It simply has a pointer to implementation. And that pointer to implementation is going to take a new implementation and pass in, just forward on the values to the constructor of the implementation. So that's my new constructor for my employee. For get name, get ID, and set name, the only differences here is now instead of directly accessing some data member, I have to go through my pointer to implementation. Okay, so that's the change in the implementation of the employees. And then, of course, the new constructors and destructors that I added to the class. Now, if your compiler doesn't support the equal default for the destructor, you could just provide an empty implementation. And for the copy constructor, I'm going to simply copy my my underlying implementation. All right, so simply I invoke the copy constructor for impl, and then my assignment operator takes the parameter by value, making a copy, and then does a swap of the internal parameters. So here, by taking the parameter by value, it then allows me to do a swap internal here. Okay, let's go back to our test program. Notice nothing has changed here. Let's go ahead and run it. So the advantage here is, of course, for this simple class, it doesn't make much of a difference. But what it does allow us to do is that any changes I make to this impl structure internally in my employee CPP file, if I change, say, ID to be capital ID, and of course I'll have to go through and find all the places that it is and change it to be capital ID. But the point is here is that this is my internal representation, and any changes I make here only affect this file, the employee CPP file. And that means that main here really doesn't even need to be recompiled in order for those changes to take effect. I can recompile the employee CPP and then relink it, whether it be dynamically or statically, and the behavior of main will still be the same. All right, let's look at it one more time. Here's my employee.h. So I have my class employee. I have the interface associated with it. I then have my implementation, which is basically just a single pointer. And in this case, I'm using a unique pointer. And then down here in employee, the implementation, I create my structure, which is the actual implementation. And this can contain functions too. Anything that would go as part of your private portion of your class can be in here, and probably should be. All right, and then the implementation here is creating the new pointer to implementation. Same with the copy constructor, new pointer to implementation, and then the assignment operator allows us to simply swap the values once we've done a copy here. Hope that helps.